Good morning and happy Monday. Today's lesson, we're going to learn how to take one specific kind of irrational number, a square root, and we're going to estimate it. I want you to understand first that this method is not completely accurate. It's just a way of coming up with a pretty good estimate. And so we're going to think about, what if I didn't have a calculator and I needed to figure out the value of the square root of 42? And I start thinking about, well, what is this around? So the first thing I think about is, well, I know the square root of 36 is 6. I also know that the square root of 49 is 7. So that means that the square root of 42 has to be somewhere between 6 and 7. So that's my first starting place. You might even think, well, it looks like it's about halfway there. So maybe it's 6.5. But I want to be more accurate than that. So what I'm going to do is then start thinking about, well, what if we broke up this distance from this perfect square, 36, to this perfect square, 49. We broke it up evenly. We started to think about 37, 38, 39, 40, 41, then there's 42. And then 43, 44, 45, 46, 47, 48, and then there's 49. And so maybe we could think of this as like each was like an even step. Now, it's not actually an even step between each square root. It doesn't work that way. But we can kind of pretend that it does to get a somewhat accurate reading. So the square root of 37, well, let's see here. From 36 to 49 is a jump of, I think, 49 take away 36 is 13. There's 13 units between 36 and 49. So we could think of square root of 36 as 6 and 0/13. And the square root of 37 would be 6 and 1/13. It's not exactly, but let's just pretend. And the square root of 38 would be 6 and 2/13. And we could keep doing this. And so let's see here, that's 3, 4, 5. So that means the square root of 42 would be 6 and 6/13. So that's my way of sort of estimating the value of the square root of 42. It's approximately 6 and 6/13. But I want to be able to estimate to 2 decimal places, to the nearest hundredth. To the nearest hundredth. Okay, so I know it's 6 point something, but I just need to be able to figure out that hundredth, and I'm not allowed to use a calculator. So I just basically need to do long division. 6 divided by 13. So then, oh my gosh, remember 6th grade math? Oops. Man, Mr. Alexander, you haven't done this in a while. 6 divided by 13 looks like this. All right, so we're going to have to actually figure out how many 13s go into a 6. So I start like this. I figure out that 13 goes into 6 0 times, but it does go into 64 times. 13 times 4 is 40, plus 12 is 52. And I subtract, and I have 8 left over, and I bring down a 0. 13 into 80. I believe that is 6, because 60 plus 18 is 78. Perfect. I have 2 left over, and I bring down, so 13 goes into 20 once, and I'm actually done now because I want to estimate to the nearest hundredth. Hundredth place is there. So I look 1 digit beyond. It's a 1. So I know that this is approximately 0.46. So that means that the square root of 42, we could approximate, is 6.46. Okay, now is it actually that? No. It is actually, if you check it with a calculator, if you round it to the nearest hundredth, it's 6.48, which means that we are off by 2 hundredths. And that's pretty close. And if we were to round to the nearest tenth, they both round to 6.5. So maybe that's good enough for our application. So what I'd like you to do on today's assignment is to practice this method. First, figure out the distance from one perfect square to another. Then convert that to a fraction using that distance as the denominator and the number of steps to your target as the numerator. Do long division, and then use a calculator to check it and see how far off you are with each one. I hope you're feeling well, and I hope to see you soon.